Good morning.
Before we start, I wanted to ask, since we have green light in Mexico City referring to COVID, in principle, we might have in-person classes at the Centro de Ciencias de la Complejidad. I mean, we would anyway have streaming, so anyone who doesn't want or is unable to go to the C3, there wouldn't be any difference, but I would just like to check whether anybody would like to go to the C3. I mean, not maybe next week or in 2 weeks, I don't know, but just to see whether anyone will be willing to or would prefer to have in-person classes, and at the same time, we will keep the streaming. If you can just raise your hand. Seems we're all very comfortable with online classes. Yeah. Yeah, for me, it's also more comfortable online because I can give it from IMAS, and it's just like 5 minutes more by bike to the C3. So, and it's going uphill. But anyway. Okay, so it seems we wouldn't have a quorum anyway, so let's keep on having online classes only. Okay. So who would like to start telling us about your potential final project? Yes, Amaury.
Okay, good morning, everyone. First, I'm going to read my proposal, and then, well, I want to ask you some questions, Professor. Okay, well, we tend to imagine the brain as an homogeneous mass whose components, the neurons, are indistinguishable from one another. This, although it may seem an adequate sketch to describe the central nervous system, is in fact a poor approximation. If we want to better understand the central nervous system, we have to change this homogeneous approach and start to think heterogeneously. Heterogeneity is almost omnipresent in many structures, from public transportation systems to social and biological networks. In recent years, scientists have explored the importance of diversity and its relation to its stability, pointing out two main types of heterogeneity: structural heterogeneity and temporal heterogeneity. From one hand, structural heterogeneity has been studied extensively in network science, and the relevance of having few elements with several interactions and several elements with few interactions is well understood. On the other hand, temporal heterogeneity has not been totally comprehended yet. Is temporal heterogeneity a key to provide structures with both robustness and adaptability? Can we extend the criticality threshold of any complex system just adding heterogeneity? In order to tackle this sort of question, I want to analyze the behavior of random Boolean networks when P heterogeneity is current. And well, that's my text. It's about P heterogeneity in random Boolean networks. And well, you sent me this paper in process. Well, was very inspiring, and I think I could understand both the main purpose and also the modifications that your team carry out to pilot the structural and temporal heterogeneity in these random Boolean networks. But maybe one of my central questions is, what do you mean by P heterogeneity? Because you mentioned this in the message that you mailed me,
Yes.
Well, maybe I can give you my perspective of why I understand by P heterogeneity, or you can direct, you can answer
Yeah.
this question there.
Yeah, so what we studied already, well, first thing that many people studied was structural heterogeneity, meaning what happens when some, let's say not all the nodes have the same number of connections, but some nodes have few and some others have many, and you can vary the distribution of that connectivity. And well, it is known that it has an effect. What we did was, okay, what happens if not all the nodes are updated at the same time? So you have some nodes that, let's say, are updated slower and some faster. And then, let's say, you can choose arbitrarily which nodes will be updated faster or slower. We tried two variants, one in which the most connected nodes, well, first of all, you can just do this with homogeneous structure, homogeneous topology, or with a heterogeneous topology. And with a heterogeneous topology, we just assign random, say, speeds or periods to the nodes. And in another version, we made basically the number, well, the period equal to the number of outgoing links. So the more nodes one affects, the slower it will be updated.
Yeah, I got that. You basically take into account four cases: temporal and structural homogeneity, temporal homogeneity and structural heterogeneity, temporal heterogeneity and structural homogeneity, and the fourth is temporal and structural heterogeneity. To achieve temporal heterogeneity, you define the heterogeneous updating function of a state that depends of this out degree. And as I understand, structural heterogeneity is performed when each node has a different in degree. And as I remember from a course that I took on network science, we have this preferential attachment. For example, in a scale-free network, this preferential attachment is a power law that depends on a parameter and the number of nodes, k in this case. Well, to prove your hypothesis in this construction, in this paper in construction, you plot the variation of complexity for these four cases that I mentioned respect to the average connectivity. Then, maybe one thing I don't understand is if this complexity is individual or if it's groupal, because you take the complexity in using the Shannon definition, right? Using a multiplication proportional to I, the Shannon's information, and I minus 1 minus I, where this I is the Shannon information. So this complexity is in principle individual or how it works?
You basically get the time series of each node, and then you calculate Shannon information on that. Basically, what's the probability that there will be 1 or 0? And you do the same for all nodes, and then you average them out.
Okay, so it's something local, and then you calculate the average of each node. Okay. And this average connectivity that, well, 2 weeks ago when we study random Boolean networks, I remember that this K connectivity, at least in random Boolean networks, is proportional to 1 over P, where P is the probability of having ones on the last column of lookup table, as I remember.
Yes.
So when you told me that I could explore P heterogeneity, this P heterogeneity case, the first thing that came to my mind was, okay, it looks like connectivity, it's pretty related with structural heterogeneity. And that is why you choose in this paper in construction 2 different probability distributions, one exponential associated to heterogeneity and one of Poisson associated with to homogeneity. So for me, P heterogeneity means that each node has a different preferential attachment. Maybe an amount of the total nodes has an exponential distribution, maybe other amount has a Poisson distribution, maybe a third amount of this total of nodes have, for example, a scaling law, no, like scale-free networks. So is this the essence of P heterogeneity, or I'm wrong?
Yeah, no, I mean, in the classical works, for example, of Derrida and Pomot from 86, I think, they analytically calculate the phase transition that depends both on P and K. So when P equals 0.5, K equals 2, but as P diverges from 0.5, then the critical K increases. And I think it's the critical K, it's, I forget, but it's like 1 over 1 minus P or something like that. But well, I forget. So it's like a curve to the right, and on the right hand you have chaotic dynamics, on the left order dynamics, and then the criticality is the phase transition. Most studies don't move P from 0.5, which is also called the bias. So it's like non-biased lookup tables. And what you can do, well, there are some studies where they do move the P, but then it's the same P for all nodes in a network. So you run, let's say, a simulation for P equals 0.5 and then equals 0.4 and 0.3, 0.2, 0.1, and 0.0, it's not interesting because then everything is 0, independently of K and on initial conditions. But then the P heterogeneity would be to have not a value for P, but a distribution. So it could be, again, let's say on average 0.5, but then some nodes will, in their lookup table, will have, I don't know, 0.4 or 0.3. And then, yeah, you kind of extract from a Poisson distribution or whatever, which could have mean 0.5, the specific P for each node. And then with that P, you generate the lookup table. So you will have different biases in each node. On average, the network should have the same bias than in the heterogeneous case, but then you will have this heterogeneous, we call it functionality. And then this gives you 4 more cases, because let's say you mentioned the 4 cases, and all of those have P equals 0.5 and it's heterogeneous.
Exactly.
And you could have the same 4 cases now with heterogeneous functionality. So it would be like heterogeneous functionality, but homogeneous topology and temporality. And all the combinations all the way to all the 3 properties heterogeneous.
Of course, and I can also play with the probability distribution, no? Maybe
yes,
I can first try
because,
with, maybe I can first try with a power law, and then with Poisson, for example, such that this probability is not constant, because as I understand, the probability in principle is constant, is 0.5, but
yeah,
we are looking for change this probability for every node.
Yes. So indeed, you could have a Poisson distribution where most nodes will have a probability close to 0.5, and then there will be some outliers. Or you could have something like an exponential or power law, where still on average, the probability of all nodes should be 0.5 or close to 0.5, but you will have few nodes that will have a probability either of 0.1 or 0, or very close to 1 or very close to 0. And most of the nodes will have very close to 0.5, so that the mean is still close to 0.5.
Okay.
I mean, it should be, since it's symmetric, it should be like with two power laws, I guess.
Yeah,
one from 0 to 0.5 and another from. But yeah, I mean, it doesn't have to be a power law. It could be just a triangle or
exactly.
some like a hyperbola or something like that.
Yeah, that depends on the number of. It depends on the number of connectivity, right? Okay.
No, this is independent of K.
Of K. Oh, okay.
So
well, last question for the moment. Which software do you recommend me in order to study this? Because well, I see that you use. I saw that you use Python or Julia,
yes.
maybe I don't know. But then in Python is right, or maybe there exists another software to run the Boolean network.
Yes, I mean, well, in principle, you can do whatever you prefer, and there are two options. One is to start from the code that Fernanda already has, because she already has the first 4 cases and the functions to generate the plots and to make the experiments and statistics and so on. Or you could make your own, whatever you think it's easier, because sometimes one might think it's easier to reuse code, but sometimes the code is not easy to reuse.
Okay, well, let me think, and I will send you a message, an email, right?
Yeah, or you can also, I mean, I send the email to Fernanda, so you can write to her with copy to me, and then take a look at the code, and then decide.
Okay, thank you very much, Professor.
Yep. Yeah, but yeah, that's an interesting thing, and I mean, the idea was to have a paper for a special issue, but the deadline already passed, so it will be for a different journal. But yeah, the idea would be to have a paper with these results.
Thank you very much, Professor. Well, another question. The progress of the project, will we have like deadlines, or when do we?
Yeah, like in about a month, there will be another round of presentations with progress, and the expectation is that you already have some preliminary results. And then let's say the final deadline, I think it's the end of May.
Okay, thank you.
Okay. Who would like to continue?
Hi, good morning. Well, if can I say my project?
Sure.
Well, I would like to work on neural networks, specifically with the study of arithmetic process. I am interested in building a neural network for the recognition of numbers and symbols. This for its application in the recognition and performance of long arithmetic operations. The interest in this is in measuring the energy and the entropy, also the algorithm complexity associated to each of the 4 arithmetic operations. Of course, multiplication and division are the most complex of the four operations due to the intrinsic properties that they have. So, well, the objective of my project will be to analyze the complexity due to each of the four arithmetic operations and, well, building the whole neural network for recognition.
So one question, what would be the inputs of the network?
Okay, yes, first to train the network, I will use a data set that it's called MNIS, I think. These have a lot of numbers, image of written numbers. I will use this package to train the network. And I also want to search for a same data package that have arithmetic operations, symbols like sums of two numbers, and do the same with the neural network that recognize the operation, understand it, and produce the arithmetic operation.
Yeah, I think there are two different tasks. One is to recognize the number and another is to apply the arithmetic operation, no?
Yes. Yes, there are two sections of the project. The first one is to create the process of recognition, then the training, and the, well, three sections. And the third one will be the operation, the whole operation. So I am thinking in working in these sections and tell you my new information.
Yep. Yeah, I understand that the goal is not, let's say, the recognition itself, because I mean, since the 80s or before, it has been shown that neural networks can do these tasks, but to study the energy expenditure, entropy, and algorithmic complexity, and so on, right?
Yes, that's the isn't new, but is the most important concept that I will working on.
Yep. Yeah, I mean, it's interesting.
Read the paper that you gave us, and you talk about the breaks in process. So I also thought about that concept because in the neural network, I will going to have problems with division and zeros and prime numbers. So I was thinking in how I can introduce this concept of break and this aspect of dividing by zero.
Yeah. I mean, the idea of Ashby of breaking is that there are some conditions in which, let's say, the rules don't apply anymore, meaning that you have new rules. And neural networks are at the same time very powerful, but very limited in the sense that they generalize what you train them with, but not much more. So in order for, I mean, I don't think that, let's say, it's useful to speak about the neural network breaking, because it either works or it doesn't.
Yeah.
So let's say, in order for the neural network to, let's say, contain the special case of divisions by zero and so on, you just have to train it with those cases, and then it will learn those cases as well.
Yes.
And let's say, in principle, it should generalize that these are an exception to the others. Yeah.
Okay. So it's a good idea, or I should change it or give it?
Yeah, I think it's interesting to compare, because as you say, one might assume that let's say addition is simpler than division and so on, but how much?
Yes.
I mean, is it twice as complex, or 10 times, or and also to estimate the algorithmic complexity will be interesting, because most probably for the addition it will be linear, but then for multiplication maybe it won't be linear. So that will also be interesting, in the sense that not just to get like, okay, one number for each operation and of, let's say, algorithmic complexity, but for different operations of increasing difficulty, let's say, I mean, it could be number of digits, how the measures that you will evaluate change. So that's why I was saying that whether increase will be linear or not.
Yes. Okay, great, thank you.
Yep. Next.
I can go next if you want.
Yes.
Hello, hi everyone. Well, for my project, I would like to implement an agent-based computer simulations of war or combat scenarios, because I think it would be interesting to study the complexity of war. So you know what, combat is a complex situation by nature. The situation is constantly changing and it requires armies to be adaptable and resilient. So I would like to explore which conditions and rules for the soldiers result in armies developing useful complex properties such as self-organization and emergent properties. So my basic idea is the following. For simplicity, the environment will be a big 2D grid or matrix in which cells could be empty, have some terrain obstacle or an unit. The simulation will run over time, and on each time tick, all agents could do an action like move, stay put, or attack some enemy in range. I would have 2 or more armies fight each other, each army comprised of different kinds of combat units, and each soldier or agent would decide their actions according to context-dependent decentralized rules. Each army would have some main goal or win condition, such as kill our enemies, destroy their base, or defend their own base, of course. So therefore, each agent would have to prioritize objectives and choose their actions according to their given rule set or combat algorithm. So, you know, this simulation would be kind of cellular automata, but with more rules and more multiple kinds of agents. So my hypothesis is that with some simple rules and enough units, the armies will display properties such as self-organization and emergence. And then my research question would be to explore which rule sets and scenarios result in complex properties, and of course, which ones let the armies accomplish their goals more effectively. And well, I realized that these simulations could expand in many different ways, and it could quickly become convoluted if I try too many different things at once. So I will try to keep it simple. My goal is to aim to achieve the most complex behavior possible using the fewest amount of agent rules and constraints, and try to avoid hard-coded behavior as much as possible. But there's some things that are essential. You know, I think there's must be some way for soldiers to have some emergent properties. So there must be some way for when a soldier has some idea, quote unquote, for it to spread to other soldiers. So there's a lot of things to decide, like how much do the soldiers know the battlefield? Do they have some aerial view, like omniscience? Or I think it's more interesting if they discover in real time the position of the enemies and they start to communicate their strategy. So communication is another issue. They could communicate instantly, or maybe only within a certain radius, so you could see how the information spreads and so on. Well, it's also important to incorporate some randomness, no? So I think in both the environment, the attacks or what is whatever in the environment, and also in the soldier's decision making, we could have entropy and see what happens. But yeah, there's a lot of different ideas that I've been thinking. You could have them fight over resources, allowing them to alter bases, set of bases, or of course, different types of units. So yeah, that's my basic idea.
Yep. I mean, it's interesting because these scenarios are something between finite games and infinite games. Mm-hmm. So finite game would be like chess. There are set rules, and let's say in principle you can explore exhaustively all possible moves. In practice, it's not computationally tractable. But let's say, for example, in politics, it's an infinite game because there is no let's say the goal of the game is to keep on playing the game. So it's not that you won already and the game is finished and then you start again. And so in this case, in war, there is an end of the game. You want to win the war, but the rules are open in the sense that it's difficult to pre-state what everyone could do. Well, that's, let's say, speaking about real war, but of course, this would be an abstraction. And I mean, game theory has studied similar scenarios already for several decades. And when you mentioned that you would explore different rules and scenarios, it reminded me of a contest that was made. When was this? I think it was in the early 90s. Let's say, perhaps you know The Prisoner's Dilemma, which is like a game theory classic. So I forget the name of the author. If someone remembers, please put it in the chat. Someone organized a competition, and he told, oh, well, send me your strategies and I will put everyone to compete against everyone in the computer. And like that, I mean, there were lots of strategies, and I think Tit for Tat won that first round. And then there was a second round, let's say, after he published the results, and variation of Tit for Tat won most cases. I think it was like that variation is that you start cooperating and then you do Tit for Tat, because if it's Tit for Tat just random, could be that you defect and then you stay in affecting all the time. But then chess is already untractable computationally, so it would be advisable to start simple and first to get results and then to add complexity. So,
I was thinking of starting with only a few, one type of combat unit, no, and try to see like it would be akin to like an immune system, maybe just the single cells trying to defend or something, and then keep adding. Yeah, variables. Because first, if you have preliminary results, that's already something, and also as you add complexity, it can give you better insights on what causes what, because if you add like 10 different things and then you run the simulation and then you get some interesting results, you don't know what is causing this. So it's like, exactly. This happens, but I have no idea why. So if you can do it incrementally, that would be good. And also with the advantage that when you run out of time, you already have the results, and that's what you turn in. Sounds good. Thank you.
Yeah. Okay. Elio, would you like to tell us more about your project? We can't hear you, Leo.
Hi.
Yeah. Yes, go ahead, Victor.
Well, my proposal final project, it's been about optimization of public transport system. It's something I worked in the past, based on one of his researchers that improving public transportation system with self-organization. It's one of the themes I study in the past, and maybe for me it's something too much interesting to work. And for this project, my idea is with my past work, I guess. I developed an app and using a agent based in, and I do a model based in agent and environment system. In that I improve genetic programming and to obtain the best route to the passengers in my model that will be my AMs. And for this project, my idea is trying to do a better simulation of this, and using that how to say that technique, the genetic programming, to get a better how to say that better data, or improve a new how to say that a new parameters for the genetic programming in that simulation, to get a better form to transport all of the agents, in that case the users of the system, to get a better transport of in the system. I'm sorry, I'm so nervous.
No problem.
To get a better transport inside of the system. In my project, I wanted to simulate that and improve these techniques in the team of the how to say this, or in the techniques of the self-organization, to trying to get that information to apply in the app, in more to apply in the app, and too much trying to apply to I'm so sorry, to apply this information in the app and get a better parameters inside of the genetic programming, to do the users can be more easy to transport inside of the system, or get a new routes outside of the how to say this aglomeramiento. To avoid agglomerate inside of the system in a certain time. My objective in this is improve that simulation and do it better, and do it a better, and do it that better this application that like that.
Yeah. Yeah, I put in the chat some related work. This was the master's thesis of Alejandro Maldonado. So it's related because we also study the routing problem, but in this case it was vehicles. And it addresses a problem that you get with, well, you used to get it already with GPSs, but now you get it with Waze and Google Maps and so on. So before there was real-time information, I don't know, like 15 years ago, and many people started using GPSs in their cars, especially in the United States and Europe. The GPS would suggest the shortest route to many people, but then that would make lots of traffic in the shortest route, so it would be counterproductive. So there were many cases where you would reach faster if you take a longer route because the shortest one was congested. With Waze and Google Maps, where you have real-time information, then you can address that and then you can take the shortest route. But still, if at the same time there are many people who want to go on a similar route, the algorithm will send them on the same route and it will be counterproductive. So what we did was trying to predict what will be the, let's say, a centralized algorithm that would predict which routes would be in the future more congested, and then try to balance all the alternative routes. So
yes,
in some cases, the optimal is neither to go to the shortest or the longest, but to measure precisely which percentage of vehicles you will send on the shortest and which percentage on the longer.
to distribute all the traffic in all of the system, but because that is one of the problems inside of a lot of this complex system, because the vehicles is concentrate only in one route, and that's but maybe for the research I read in the past, that's one of the problem in this, because all people going only in one route, and maybe in the shortest, or maybe on the for the data in his environment say to do to go in that route. But in all of the researches I read, maybe get another alternatives to transport this and get more efficient for this type of routes, and doing the system transport system be more balanced for all of the transport.
Yeah.
Not only for the people's for another type of transport.
Yes, that I mean, in theory that seems appealing, but in practice, most people will not change the routes, especially in public transport. And there was a study from the Metro of London that there was a disruption and they closed some stations or some lines. And well, one advantage in London is that with the Oyster cards, you can detect where people go in and where they go out. So it's not like here that we just know how many people go in at every station every day, but we don't know where they go out. We don't know which route they take. Well, also in London, you don't know which route they take because there's redundancy. But it was known that several people after that disruption changed the route completely, because it turns out that they couldn't take their usual route. They took another one, and it turned out it was better for whatever reason. Maybe not in time, but less crowded or whatever. But that reflects the fact that why they require a disruption to find a better route, because they don't change. And also, if you build an app that will give you information about public transport, maybe people will use it when they go to a place that they have never been to. But most people, for their daily commute, they don't explore new routes. And also, in many cases, drivers do the same. They go on the same route, and it's. I mean, I don't know which percentage, but I can imagine not every driver switches on Waze or Google Maps and then sees what's the best route at that moment. Because in some cases also the difference is like, well, it's 3-minute difference. I won't bother. Yeah. So I mean, what I want to say is that in theory it might be interesting, but in practice, I don't think many people would use such information. So I could suggest an alternative, but well, the disadvantage is that we depend on other people to perform it. But we've had several talks with the director of mobility of UNAM, And we have proposed an algorithm to regulate public transportation systems, and this could be applied to Puma buses. I mean, also it could be applied to Metro buses, and actually the fifth line of the Metro bus already has all the equipment. So I was trying to convince the director of Metrobus just to let me speak with the drivers so that they would just try our algorithm, because you don't need to invest anything. You just need to convince them to drive in a specific way, following certain rules, and then just to measure the improvement. That's it. And they have GPS satellite monitoring. So, I mean, you don't need to do anything, just zero investment.
Yes.
But yeah, no, because it's difficult to speak with drivers' unions. And also here, the drivers of Puma buses are in the union, so they get picky if you ask them to do something extra. But anyway, I want to suggest maybe to explore to work with the Puma bus drivers to try to implement this algorithm and to measure what are its benefits if drivers follow it. And of course, I mean, at the C3, we already had access to the GPS data. Actually, we have lots of GPS data stored from before the pandemic. And right now we don't have that data, but then if you agree, then I can send an email to the director of mobility so that we get, again, access to that data. And then we could try to convince the drivers to try this algorithm and then measure the difference.
Yeah, for me, that's interesting. Well, for me, that's something interesting to study.
Okay, so I'll send an email, put carbon copy to you. But since this would depend on many external factors, let's have a plan B in case nothing moves.
Okay.
And let's try this not for a long time. And if it doesn't work, then we go into something else.
Yes.
Yeah. But let's try it. I'll send an email later. Okay.
Thank you very much.
Yep.
Yeah. Hi, and I wanted to discuss a little bit about the proposal I was thinking to make, because it is very related to what also Victor proposed. So it's a little bit overlapping, but I still haven't cleared up really what I wanted to do, and I have 2 or 3 proposals in my hand. So I wanted to discuss them with you before committing to them. So one of them was really related to this topic of public transportation, or let's say more to the idea of city as a living system. And I took inspiration from one of the paper that I read that from you, I think, also. And what I wanted to, I was thinking of doing is due also to the time constraint. I mean, we do not really have a really long time to develop something, a really complex and elaborate project. What I was thinking about was of trying to replicate some of the results in the, let's say, operative part of the paper. So where, for example, you show that you have slower is faster effects, right?
Yes.
And all these kind of emergent phenomena, try to replicate them, for example, with more detailed parameterization, or for example, in a data-aware manner. I don't know how to say it, or comparing the simulations to real-world data in different cities. I don't know if also this can be also a little bit very long and elaborate, but my hypothesis was trying to replicate these simulations and I wanted to also know what you thought of this. And I have also 2 other proposals, but they are less grounded on truth and less possible, let's say. And yeah, one is about robustness. So exploring robustness in a general manner, but I don't know how it is really possible, because it's also theoretically elaborate, let's say, to conceptualize this in terms of equations and blah blah blah. For example, I've from a project when I was at during my bachelor, I studied the robustness of optimization problems, and I was asking myself if these types of properties could be also I'm sure it is possible, could be parameterized also for simulations of autonomous systems, adaptive systems, etc. So this was one. The second idea, and the third idea that I have not still yet developed, but that could be interesting in my perspective, was to understand how compositions of music, especially those like, I don't know, jazz compositions or music from Johann Sebastian Bach, can be thought of as sequences of states that have some kind of relationship one between the other, and so that can be interpreted as as systems that have as adaptive systems that somehow go into another state, and then they go into the next state, and then they come back and restore the original state, and somehow they do this, especially jazz, in an adaptive manner. So somehow improvisation in jazz has some rules, but it has some element also of stochasticity. But this doesn't diverge because it's always a finite product. It's always the final product is a song. So that was another hypothesis, but I really do not know how this can be really applied, if this has a practical implication. But it would be really interesting. I don't know. These were my 3 proposals, and I wanted to ask you a comment and discuss about this. Thanks.
Yep. Yeah, all 3 are interesting. For the first one, maybe you could try to find something like necessary and sufficient conditions for example, the slower is faster effect to arise. And also, if you do a exhaustive exploration of the parameter space, then you could find like, okay, in this region of the state space, this happens, and in that region, you have this different behavior, like trying to detect phase transitions. Assuming that there are phase transitions, it could be that if there are no phase transitions, then it's not very, let's say, insightful to have an exploration of
also in a very
space.
idealized manner, like on a lattice or something like that.
Yeah. And about robustness, it's a very general concept. So it is easy to kind of have a general measure of robustness. I mean, following Andreas Wagner and how he defines it, it's like, okay, something robust is something that continues functioning in the face of perturbations. So you could propose a measure of robustness that kind of is the inverse of the deviation from the expected function. So maximum robustness is when the perturbation doesn't change the function, and then minimum robustness is when the smallest perturbation changes drastically the function. So actually, let me share a paper. Well, in the antifragility paper, our measure of antifragility in random Boolean networks, this measure of fragility could be seen also as a measure of robustness, in the sense that robustness close to zero, fragility close to zero is robustness. And When it's positive, the greater it is, then the more fragile the system is. And when it's negative, then it's antifragile. This means that when this fragility is negative, the system performs better in face of perturbations. When it's zero, the system performs as well with perturbations, no matter how big the perturbations. So let's say this measure of robustness, it can be done, but then to generalize it over many different systems can be tricky because you have a kind of no free lunch situation where in some contexts you are better off with lots of robustness, and in some others it can be even detrimental to have robustness. If you want something that is very sensitive so that it can adapt quickly, then you need something that is not precisely robust, or that is not too robust. And when you want something that no matter what happens, it will continue doing whatever it's doing, then you need high robustness. So yeah, I mean, it's interesting, but then it might be difficult to generalize. And for the last one about music, it's also interesting. Probably some people from dynamical systems have done something similar, but I can imagine that you could try to describe musical pieces in terms of state transitions and try to find attractors. I mean, it is known that in some Bach pieces there's recursion, so whether that recursion would lead to some self-similarity in the state space or not, it's something to explore. Probably yes. If you want to have like a, I mean, is that we did this with another student that we were applying a measure of multiscale entropy for different songs and then comparing the popular songs from the top 100, I think from Billboard, with the rest from a music database. And this entropy was a bit higher, not always, but on average it was slightly higher. But then we could take advantage of the crowdsourcing from Toloka. So for music, you could ask people to evaluate some aspects of music that are not necessarily existing music, but like short pieces, and then you could make people evaluate something. Amaury put in the chat a link to the Santa Fe Institute podcast. So entropy, you can see it as a measure of disorder, but then you can measure it at different timescales. So for example, you can measure the entropy in text at the letter level, or at the word level, or the sentence level. Or in DNA, you can measure entropy at the codon level, or the triplet level, or the gene level. So let's say this multiscale entropy applied to music, it's, let's say, you have like a different measure of entropy for different timescales, like 1 note, 2 notes, 3 notes, and things like that. And the idea of studying all of them at the same time in what is known, what it's called a profile. So it would be like the entropy profile at different scales. That gives you a better idea, gives you more information than just focusing on a single scale. Because, I mean, there are some phenomena that might have high entropy at low scales, but very low entropy at higher scales. Like white noise, that is one example.
You're saying like scales. That it gives you a bandwidth where phenomena happen, and you say, okay, analysis in this bandwidth is more meaningful than in other, with respect to other parts of other bandwidths?
You don't assume the scale, you explore all scales, and then you see which ones have which entropy. because let's say it's something which is very chaotic would have high entropy at low scales, but then when you increase the scale, it kind of averages out. Something which is like very monotonous, it will have low entropy at all scales. But something that is complex, let's say the extreme case would be something self-similar, it will have high complexity at all scales, or high entropy, or higher entropy, because it's the highest entropy, it's let's say randomness.
Okay. Thank you. And yeah, I will need to explore a little bit more these proposals. But yeah, if you have any suggestion about papers or material to read, I would be very glad to explore it also in the next weeks.
Do you have in mind this paper of antifragility measure? That, I mean, you could use that as a measure of robustness. I'll put it here in the chat.
But yeah, so before you were discussing about the fact that you know, you sometimes want more fragility or more less fragility, and apart from that, is there a universal conception, quantitative conception of robustness that can be made in such a way that I can then compare, let's say, pear with apples? So I have research from music, and I have research from biology and research from epidemiology, and then say, okay, in such a way that we have entropy, define a measure for robustness. Is there a way that we can do that?
Yeah, maybe you could use Fisher information, which could be seen as the derivative of Shannon information in some particular cases, which is how much information you gain when you change a variable. In theory, it works. In practice, it's difficult because you need the ability to change the information, and in most cases, you just have data, and then that's not. You cannot fiddle with that data anymore. But yeah, it could be something like the inverse of Fisher information, because something robust is like when you don't have a change of info, you don't gain information or lose information when there's a change, so that the information remains constant independently on whether it's high or low information. And that would be an equivalent of saying, well, the function is continuing, but you could just arbitrarily say, well, I will define a parameter between 0 and 1 of robustness, and it will be 1 if in presence of a perturbation it exhibits the same function, 0 if it's completely different or anti-correlated, or non-correlated, and -1 if it's anti-correlated, or if you want to use correlation, or it could be 0.5 and 0 if it's anti-correlated, like something like a Hamming distance.
Okay, thanks. I will look more into that.
Yep. Yes, Arodi.
Okay, hi. I still don't know what will be my project, but I wanted to read what I sent. So if anyone has an idea or paper that could share with me and I can use, I think that would be useful. So, well, with my collaborators, I've been working on interpersonal coordination. That is the phenomenon in which individuals unintentionally coordinate their behavior with each other during social interactions. In our first paper, we put forward the hypothesis that during spontaneous interactions, the complex way in which the behavioral rhythms of the participants interact could lead to an emergent collective rhythm with which individuals could coordinate, and that is similar to a musical beat. We recently characterized this group level rhythmicity in small group conversations and found that their structural complexity differs from random and isochronous patterns, and that this complexity changes over time. The next step will be to analyze whether these group level complexities are emergent. And we will do this by analyzing when and how much information is transferred between participants and between them and the collective rhythm. So as I said, I still don't know what will be my final project, but I would like it to be related to the information dynamics of this last stage.
Yes. So do I understand properly that you already have some data?
Yes. Yes, we were analyzing this rhythmicity of acoustic behavior in conversation. There is a time series of onsets of acoustic events.
Yeah, so I guess it would be wiser before getting more data to analyze the one you have and then see whether you need more or not. Yeah, so for information transfer, are you using transfer entropy?
Yes.
Or which one?
Yes.
Yeah. But then you already got some results with that, or you're in the process?
Not the good ones. We carried out some analysis, but they are not correct because I need to change them.
Yes, sometimes when you are measuring information-related measures or entropy-related measures, the timescale is very tricky because indeed, if you kind of look at the very high timescale, then you will not have enough statistics to be able to get, let's say, a meaningful measure out of them. In sense, if all instances are unique, then you cannot distinguish which ones are more probable than others.
Okay.
And then if you have too much data and then everything has the same probability, then let's say you have maximum entropy and you can't distinguish anything from noise. So maybe, I mean, I can imagine that it's more difficult to get more data rather than trying to have a different analysis with the same data. But one option might be to, and if you aggregate the data, then you will get even less points.
What do you mean by aggregated?
Yeah, so instead of looking at interactions, you look at interaction sequences, like, I don't know how many different interactions you have.
4 people, 5 people in a conversation.
Yes, but
what do you mean?
What do you measure? Like just interaction, no interaction, or speak?
No, we measure the group level temporal structure of the acoustic behavior. I don't know if I understand your question correctly.
Well, yeah. What are you measuring of the conversation? Who is speaking with whom, or what are they telling to whom, or who is listening to whom?
Okay, and what we already did was only at the group level, and now the part of information transfer will be about who is influencing whom. I don't know how to explain it, and I don't think I'm
Okay.
sorry.
Yeah, I mean, the key is to find the proper scale, because if you are kind of looking at the specific words that somebody uses, and then you are trying to find those same words in what another person uses, that might be too specific, and then probably you won't find much correlations, or not all the influence that is actually occurring. And then if you go to the other extreme, that you just measure whether someone speaks, and then you consider that as 1, and then when they don't speak, that is a 0, then that might be also too simple. So I mean, I'm just brainstorming. I don't know, maybe.
Yes, and I couldn't explain to you. Okay, I have 1 month to figure it out, so maybe
yes.
The next time I will have it.
Yes, if you play with the data that you have, and also trying, let your questions guide you. So if you are trying to find, okay, when, let's say, this collective phenomena is occurring, or when coordination is occurring, then that will help you guide, okay, how can we measure coordination? Because I mean, you can try so many things, but then to select from all those different alternatives, your research question will be what will guide you.
Okay, yes. Okay.
Okay. Yes, Jose Alberto.
Good morning, everyone. So what I want to do for the final project is to explore the emergence of language in a population of artificial agents, similar to what has been done in experiments such as the Talking Heads experiment and other similar experiments. But in these works, the main focus is on analyzing specific features of language, such as concept acquisition, and how these concepts get coordinated to give rise to a shared language. And my interest is to explore something similar, but in my case, I'd like to analyze grammar features of language. In particular, I want to explore syntax formation, which is a little bit more complicated, because in this case, meaning is expressed using a set of or a collection of words that are organized hierarchically. And so I think that the main challenge is to find the correct rules to give rise to the emergence of this syntax. And also, I don't know if this is a good project for me, because I have little knowledge about linguistics. But yeah, that should be my project. And also, because I have a physics background, I think that I could perform a statistical analysis of these simulations, because we can consider a possible universe of languages, and each initial configuration and evolution can be considered as the element of an ensemble, and you can perform any simulations and study the statistics of these simulations to analyze the dynamics of the system.
Yeah. Yeah, I put a couple of links in the classroom, but in the chat I'm putting even more. The first two are of a recent book by Morten Christiansen about language games, and they speak about evolution. And the other two are specific about grammar, which is more complex than just evolving a shared lexicon.
Thank you. But do you think that this is a a good project for me, that considering that I don't have a solid knowledge of linguistics.
Yeah, I mean, grammar is a big bite to chew.
Yes.
Maybe you could start with trying to replicate some experiments, and then that exercise will give you a better understanding. And if you, I mean, that could be already enough for a project. And from there, you could also make variations. Like, okay, what happens when, let's say, we add this capability or we restrict this property? Or as Shoichi was suggesting, to have a detailed exploration of the parameter space, because in many cases they show like, oh, we did this and it worked. And then a further question is like, well, under which condition it works and when it breaks down. So let's say trying to focus on necessary and sufficient conditions. Like, okay, what's the minimal things that you need to evolve a shared vocabulary or grammar? And if you start removing things, when does it break down, or how does it degrade, or does it affect at all, or maybe it even improves things, or it makes things slower, but anyway, they converge. Or if you add this, whether it improves or not.
Okay.
So I suggest you read more about it and start playing with it. And if you, let's say in 2 or 3 weeks, see that you are advancing, then carry on. And if you see that it's like a huge mountain to climb and there's, let's say, that it would require, let's say, several months, then it might be better to reframe the project.
Okay.
Either in language games or in something completely different.
Thank you, Doctor.
Yep. Odin?
Hi. Well, I hope I can do it fast and with not much noise around. Like if you feel a lot of noise, just let me know. Quite quick enough. So, well, the things like we've seen during the course, few biological interactions or biological examples that generate complexity and they are adaptive. For example, the regulatory neural networks that we've seen, and also the trophic networks. But one very particular that I've been doing some research in the past, more than 10 years ago, but still unfinished, is on the mutualistic plant pollinator networks. And one of the characteristics of that interaction is particularly that there is a very delicate equilibrium or conflict of interest between the plants and the pollinators. So to say very, very fast, the plants want some bees and any other animals that pollinate them in exclusivity. They like fidelity because otherwise they are wasting nectar, right? Meanwhile, the insects just want the other way around. They want to visit as much as possible. But the funny thing is like the plant can choose because the plant can make strategies just to kick out bees or many other animals, right? So if you model that, if you think about that, you can imagine like a very complex system that evolves over time and probably never rests. It's always evolving or always adapting, right? The funny thing is like most of those models has been, this interaction has been modeled either as a game theory or as an ecological interaction. And both of them almost make explicit the shape of the network or study certain networks. Even me, I was working on nestedness many years ago with differential equations. But many of them don't allow like the social interaction or social choice theory. So don't let the plants choose and don't let the animal choose. And I think like implementing that shouldn't be that complicated in the sense like making a little game, like agent-based game, right? Like many plants, many animals, all with all, and then some efficiency parameters that can be fluctuating between 0 and 1, adapting to them. Well, to maximize gaining, right? Through rewards in the animals, pollen acquisition in the plants, and then it can be studied the whole community and the individuals, getting something similar to what is called like Hume used to say. I have it written here. Sorry, the tragedy of commons, which Elinor Nostrom sort of proved that it has a proper solution that don't need to be a tragedy. And maybe in this case, we can find also a solution that can be used for any other market situation. And the funny thing is, like, even if there is no a previous hypothesis, it allows you to study generalization versus specialization, maintenance of cooperation, and Carlos mentioned Axelrod competition in the past that has been going on for more than 30 years now. And well, and there are certain other aspects like the robustness of the system, the antifragility. I think once the system is built, it allows for many questions to be answered somehow. Particularly because the difficulty in here I find is like to find the multi-objective optimization, like per plant, per animal. That's what can be very tricky.
Yeah. Yeah, it's interesting. Do you know about the red queen effect?
Yeah.
Perhaps you can also relate it to this, because it's like with arms races, that one evolves something and then the other evolves in the same direction, like also evolution between predators and prey. That's
why the Pareto is so curious, right? Because it seems like a Pareto delicate. In biology, I need to read more about that, but it seems like it has proliferate queen effects. So they have now the queen, the black queen, the black king, the red king, the red queen, and I have to read a bit about that. No idea what it is.
Yeah, and no, I agree that many people have studied this with game theory because it's like the natural thing to do. I mean, there's the mathematical tools, but it gets complicated because, so for example, even if you derive or define a payoff matrix, since you are looking at this at an evolutionary time scale, then the payoff matrix is also evolving with the changes that you find. So it's much more difficult to have concepts similar to Nash equilibria or evolutionary stable strategy when you have these changes going on and you don't know where they're going.
Exactly. So
the evolutionary trajectories, I mean, you kind of trace them as they go in a simulation, but it's difficult to say like, okay, you will always go from here to there because of the nature of the evolutionary process.
So what I see interesting in this version is exactly the adaptive computing side of it, right? Like it's exactly what you mentioned, that rather than try to study a network that's predetermined, now it's like we leave the method or the algorithm flows and see what is the best solution. Probably modular. I mean, if there's some tendency to destroy plants or whatever, like extinction of plants, probably modular is going to be more a better kind of network, or nested, or different kind of things. So it's very easy to explore once you get this over. Thank you.
Okay. Well, we're out of time, so let's start on Thursday with people who still have to share in. Could you please raise your hand if you still have something to share to get an estimate? Yeah, let's start on Thursday, and if we have time, we will discuss paper of Ashby, and if we need, we will extend with Ashby's paper for next Tuesday. But yeah, if you haven't done it, upload to your ideas to the classroom, and for next Thursday, meaning in 2 days, also upload your comments and criticisms of Ashby's paper. So see you on Thursday.
Thank you. See you. Bye.
Thank you.
Thank you very much.